Hello friends, this is the another problem related to Kirchhoff voltage law and Kirchhoff current law. This problem contains two current source, two DC voltage source and one dependent voltage source. So in this problem you have to calculate the node voltage V1 and V2. So you have to calculate node voltage V1 and V2. So this voltage and this voltage. How to calculate this? We have to use Kirchhoff voltage law and Kirchhoff current law. So if I apply KCL at node 1, this is a one node, okay, and this is a node number 2. So this is incoming current and this is outgoing current, this is outgoing current. So from this node we can say that current through this branch 10 ohm, it will be V1 minus 20 divided by 10. Okay, so current through this junction is V1 minus 20 divided by 10 ohms. Okay, now you have to calculate this current through this resistance. So this resistance value is 5 ohm. Okay, this is 5 ohm resistance. So current through this 5 ohm resistance you have to calculate. This is V2 and this is dependent voltage source 0.5 V1. So this is plus. So total voltage is V2 plus 0.5 V1. So current through this direction it will be plus V1 minus 0.5 V1 plus V2 divided by 5. So this is the two leaving current from this node 1 and 1 is upcoming current, this is 2 ampere. So it will be 2. So if I solve this, then it will be .5 V1. If I subtract V1 from V1 minus 0.5 V1, so it will be plus 0.5 V1 minus V2 equals to 2. So it will be 10. So it will be V1 minus 20. It will be V1. It will be minus 2 V2 equals to 2. So or this is 2 V1 minus this is 2 V2 equals to this is 20 and this 20 will be plus 20. So or 2 V1 minus V2 equals to 40 or V1 minus V2 equals to 20. So this is the equation number 1 from the node 1. Similarly, if you apply KCL at node 2, similarly applying KCL at node 2, here you see that these are leaving current, these are leaving current, these are leaving current. So the incoming current is 5 ampere. So current through this branch current through this branch 10 ohm resistance, it is V2 minus 30 divided by 10 plus V2 divided by 2. So current through this junction, resistance 2 ohm, so it will be V2 by 2. Next, current through this junction will be plus V2 plus 0.5 V1 minus V1, this voltage minus this voltage, divided by 5 must be equals to this 5 ampere. So it can be written as V2 minus 30 divided by 10 plus V2 by 2 plus it will be V2 minus 0.5 V1 divided by 5 equals to 5. So if I simplify this equation, so it will be, if I want to simplify this equation, so this is 5, 2 and 10, so it will be 20. It will be 20. So 20 means 2V1 V2 minus 60 plus 2, I mean 10 V2, it will be 4 plus 4 V2 minus 2 V1 equals to 5. So this is V1 is minus 2 V1, minus 2 V1, V2 is 2 V2, that means 12, 16. So plus 16 V2 equals to 100 plus 60. So it will be 160. So this is the equation number 2. This is a equation number 2. So you can also simplify by taking common 2 from this equation. So this is equation V1 equals to 20. If you take 2 common from this equation, so it will be minus V1 plus 8 V2 equals to 160. So this will be cancel out 80. So it will be minus V1 plus 8 V2 equals to 80. So this is the equation number 2. Okay. If you solve these 2 equations, then you can easily calculate what will be the value of V1 and V2. So if I solve these 2 equations 1 and 2, so simply add these 2 equations. So adding 1 plus 2. Okay, so this is plus V1, this is minus V1, so it will be cancel out. This is 8 V2 plus minus V2, so minus V2 plus 8 V2 equals to 20 plus 80. So it will be 7 V2 equals to 100. So V2 equals to 100 divided by 7. So if you divided 100 by 7, so it will be 1.285. Okay, this is the volt. Similarly, you can you can write the value of V1. So from equation 1 you can write that V1 equals to 20 plus V2. So equals to 20 plus 14.285. So it will be 34.285 volt. So this is the